Hello, everyone, and welcome to this Monday night Tortoise Thinking on what, to my mind, is the ultimate slow news question. Are we alone in the universe? My name's Giles Whittell. I'm an editor at Tortoise, and I'm a bit of an old-fashioned curmudgeon and a believer that all stories, all news stories, need a peg. And in conventional news, an answer to the why now question. In conventional news, the peg is something that probably happened last night, maybe this morning, or in Fleet Street journalism, it is about to happen. At the very least, it happened sort of last week or last month. But one of the great luxuries of slow news is that we don't have to be fussy about that kind of thing, and especially when the peg is as good as this one. It happened 4 years ago, and I'm not going to try to explain it in detail, but an interstellar object passed through our solar system very fast, around the sun, past Venus and us, and headed off out of the solar system again. And it was just and so picked up by human astronomical instruments. And there the story might have ended, but for the fact that a very grand astronomer spotted it, as it were, keeping his eye on the data, analyzed it, and came to the conclusion that the only, or at least the best explanation for this interstellar anomaly was that it had been created by an extraterrestrial civilization or intelligence of some kind. And we are very lucky that that astronomer, Professor Avi Loeb of Harvard University, is with us tonight. And as I say, I'm going to let him start in a second by putting some chapter and verse on that very spare outline of the story that I've just given you. Sarah Cruddas, our other guest tonight, is a science and space journalist who's written many books on space and also took part in the 2019 Discovery Channel series Contact, about the question of whether we have already had contact from extraterrestrial intelligence, not in the Hollywood alien type, but real contact of the kind that Professor Loeb has also immersed himself in investigating. So I'm hoping that Sarah may be able to step in with some informed examination of Professor Loeb's position while I just look on in slack-jawed wonder. Now, this is a think-in for those of you who've not been to one before, and there always are some. The bottom line is, please, it's an opportunity, well, it's an opportunity for civilized disagreement, as the slide said before we started, but also basically for you all to pile in. You can do so by raising your digital hand. You know the drill probably from other Zoom calls. Tap reactions, the hand will come up and you can raise it, or get involved in the chat, or both. Now, Avi is in the middle, I know, of a sort of maelstrom of global interest in his book, Extraterrestrial, which I have in Kindle form, so I can't lift it. Hello there. Great to see you. I know that you've probably just moved to us from another interview, and you've been doing it pretty much nonstop for years, but it's great to have you. And in answer to your question, no, you don't need to do slides. This is just Q&A. And as I was just saying, we will try and bring in lots of input from audience members, either whether they raise their hand or through the chat.
Well, thanks for having me.
Yeah. Oh, great to have you. I'm presuming you're coming from Cambridge, Mass.
Nearby. I'm in
Lexington.
House arrest. I'm in house arrest not because of my colleagues, but because of the pandemic this time around, unlike Galileo. But I should say that also that it's a great pleasure to join you. And indeed, over the past 7 weeks, not years, but just the last 7 weeks, I had back-to-back interviews from 8 a.m. till 7 p.m. So It was a bit exhausting, but I used it as a platform to communicate the excitement that we can have in doing science. You know, science is not supposed to be boring, as one often gets the impression.
Right. Well, look, your book, which in some ways is an elegy to your upbringing in Israel, right through to you falling in love with science and your wife and your incredible career trajectory at Harvard and elsewhere. But can we dive in the middle, as it were, because by 2017, you had already become involved with Yuri Milner, the entrepreneur and benefactor, and had suggested to him a way of getting a tiny spacecraft to the nearest Proxima b, a planet near Proxima Centauri, in a way that could get there and transmit a message back within his lifetime. That was, and the propulsion method was a solar sail driven by a high-powered laser. And I only go through that to sort of lead us in, because then Oumuamua happened. Can you tell us the who, what, where, why, and when? By that I mean where you were, and sort of set the scene for us, how you first came to hear of it, and the processes in your head that made you realize this may be something.
Right. So I should say, start with a preface that I worked most of my career on the first stars in the universe, let the scientific version of the story of Genesis, Let There Be Light, and also on black holes. And I applied the same approach to this object when it appeared, the same scientific methodology that I applied to past anomalies in those areas that I just described. And I was naive in a way, because I didn't expect the reaction to be so dramatic. But at any event, this object, Oumuamua, was discovered on October 19th, 2017, by a telescope in Hawaii on the Haleakala summit, and was given the Hawaiian name Oumuamua, that means a scout in the Hawaiian language. It was the very first object we discovered close to Earth that came from outside the solar system. It's sort of like finding an object in your backyard that came from the street, and that allows you to learn about what's going on in the street without needing to visit the street. I mean, it takes a long time to travel to the nearest star. The nearest star is 4 light years away. So light takes 4 years to get there. Actually, only this month, they received the signal about the 2016 elections in the US. So it's really a very long journey, even if you move at a fraction of the speed of light, like we contemplated with Yuri Milner's funding. Avi,
therefore, yes. Can you just explain for people who haven't seen the book yet, or indeed some of the coverage, how did you and the scientist who was in Hawaii monitoring that telescope at the time know that it was interstellar rather than an asteroid or something?
Well, that's very simple. It moved too fast across the solar system to be bound to the sun. We all know that if we send a rocket that is fast enough, it escapes the gravitational pull of the Earth. But if we throw a tennis ball up, it comes back down because its speed is not high enough to escape from the gravitational potential well of the Earth. And so this object was simply moving too fast to be bound to the sun, just like a very fast rocket that we can launch away from Earth. And so it means that it exhibited a one-time appearance in the solar system. It came from outside the solar system, unlike all the objects that we have seen before, comets or asteroids. So it's relatively easy by monitoring the trajectory of an object to tell whether it's bound to the sun, like a planet. You know, the Earth is moving around the sun for a lot of times now, simply because it's bound to it. Right. But an object coming too fast will just pass near the sun and then escape. And this was an interstellar object of this type, the first one detected, simply because prior to this telescope, the Pan-STARRS telescope, we didn't have a sensitive enough instrument that would monitor the entire sky and would detect objects of this type. This was the very first telescope, and after a few years, it discovered Oumuamua. Its original intention, I mean, this telescope was designed to find near-Earth objects. And that was a task that the Congress, the US Congress, gave NASA to find 90% of all objects bigger than 140 meters that will come close to Earth because they pose a risk. We know that the dinosaurs were killed by an object as big as the island of Manhattan. And we don't want to face such a catastrophe. So we're trying to find all the objects. We have the human brain, you know, much smaller than the body of a dinosaur, but it's much more precious for survival. And we can figure out which object is coming towards us using the laws of Newton, and then try to perhaps nudge away those objects that are dangerous. So that was the purpose of the Pan-STARRS telescope. In surveying the sky, discovered the Oumuamua. And at first, astronomers thought, well, it's probably just like the rocks we have seen in the solar system, just came from another star. The only problem is it didn't look like a comet. It didn't have a cometary tail. You couldn't see any trail of gas or dust around it. And the Spitzer Space Telescope looked very deeply around it and couldn't find any carbon-based molecules or dust at very sensitive levels. And it was clear that it's not a comet. It had it reflected sunlight. That's how we could see it. And as it was tumbling around, the brightness of this object changed by a factor of 10, meaning that projected on the sky, it was at least 10 times longer than it was wide. A very extreme geometry. Just imagine a piece of paper tumbling in the wind. The area that you see in front of you will not change by more than a factor of 10. I mean, it's very unlikely for it to be exactly edge on. So clearly, and also the best fit model to the variation in the light curve of this object was that of a pancake shape, a flat object at the 90% confidence. So not a cigar shape, but a pancake shape. And then
let me, sorry, just if I could jump in there. As you know, the artist's impression that has taken hold and has been reproduced again and again in the media is more of a cigar, isn't it? Do you think
that's wrong. So
okay.
This was an artist illustration based on the initial information that we had, that it needs to be at least 10 times longer than wide, projected on the sky. So if you imagine a piece of paper projected in front of you, it looks like a cigar. I mean, because it's elongated, but that's just the projected image. Intrinsically, the piece of paper is flat. So that's what we figured out by analyzing the reflected light from it afterwards. So that took another couple of years to figure out what the reflection of light implies. And indeed, it implied that it's most likely at the 90% confidence, most likely pancake shape, flat. So this artist illustration that was created a few months after the object was detected is wrong. Okay, it's just projected on the sky, it looks elongated. And then another very unusual feature of this object was that it exhibited a push away from the sun that in addition to the sun's force of gravity. And usually such a push is obtained from evaporating gases that give it the rocket effect that push it forward. But there were no gases around it. And so the only possible interpretation was that the reflection of sunlight is giving it a push. But for that, the object...
That's the only possible interpretation. I want to get on later to the reception that some of your hypotheses have elicited from the rest of the scientific community. Excuse me, communion. Freudian slip. But is it really the only possible explanation that it was being pushed by photons, as it were?
Okay, so to me that was the most likely interpretation, but so I wrote a paper about it, and it implied that the object needs to be thin. It needs to have a large area for its weight, so that it can be pushed by reflecting sunlight, sort of like a sail that you find on a boat, except being pushed by light. And nature doesn't make such sails. It has to be artificial. But then in the subsequent couple of years, there were several other scientists trying to explain this push. And one of them suggested that maybe it's made of pure hydrogen, that when the hydrogen evaporates, you can't see it. Hydrogen is invisible. and it just behaves like a comet, except you can't see the cometary tail. Now, the problem with that is hydrogen can evaporate very easily by absorbing starlight. So we showed in a subsequent paper that it wouldn't survive the journey. You can't have a hydrogen iceberg the size of a football field survive the journey over millions of years through interstellar space. So it's not a viable explanation. Then there was another suggestion. Maybe it's a dust bunny, you know, the kind that you find at home, except the size of a football field and 100 times less dense than air. So it's so porous and fluffy. It's just like a dust cloud, you can think of it. 100 times less dense than air. It's so lightweight that it can be pushed by reflecting sunlight. And the problem with this idea is that as the object gets close to the sun, it gets heated by hundreds of degrees. And in my opinion, it wouldn't have the integrity, the material strength to keep itself bound. It will just dissolve. So these were the two suggestions trying to explain the extra push without us seeing a cometary tail. And in my mind, both of these suggestions suffer from substantial flaws. And all I'm advocating is, both of these suggestions invoke something that we have never seen before. So I'm just saying that the artificial origin is a very viable possibility given the alternatives, and that we should get more data, more evidence on the next object that comes around that looks as weird as Oumuamua, and we will find one within a few years. Because, when I go to the kitchen and I find an ant, it means I get alarmed because it means that there must be many more ants out there. And the same with Oumuamua, there would be more objects in the coming years. And we should send a spacecraft that has a camera that will take a photograph, because they say, a picture is worth 1,000 words. In my case, a picture is worth 66,000 words, the number of words in my book.
Okay. Well,
one more comment there, maybe.
Yes, please.
A few months ago, in September 2020, there was another object found that exhibited an extra push away from the sun by reflecting sunlight without a cometary tail. And it was given the astronomical name 2020 SO. And then the astronomers that discovered it with the same telescope, Pan-STARRS, realized that it actually came from Earth. If you go back in time, in 1966, there was a rocket booster that was launched into space, and as part of a lunar mission. And we know that it had very thin walls and was hollow, and that's why it could have been pushed by reflecting sunlight. And we know that this object was produced by us, that it's artificial. The only question is, who produced Oumuamua?
That's amazing. I didn't know about 2020 SO. Well, look, Professor Loeb, or Avi, if I may, we'll come back in a few minutes to the paper that you wrote and the reception that it got. But if I can come to Sarah Cruddas now. Sarah, do you think you could give us a little bit of the context before Oumuamua, if I'm pronouncing it right, arrived on the scene? Where had we got to in terms of the are we alone in the universe debate? I think that you've sort of declared your hand on one side or other of this debate, but I'll leave you. Oh, okay, I'll leave you to say what you think. But where were we, and how do you think Professor Loeb's work has affected it?
Well, thank you very much, and thank you so much for everyone for having me this evening. My background is in astrophysics, not so much as high a level as Professor Loeb, but it's it's a cliche, but to quote Carl Sagan, extraordinary claims require extraordinary amounts of evidence, and we just don't have that cliche piece of evidence just yet. I could say to you, I think I believe in aliens, or I think I don't believe in aliens, but that would be religion. It isn't science. And at the moment, we haven't got scientific evidence to say conclusively that we are alone, or that we have, the universe is teeming with life. One of the most important developments in recent years, or two of the most important developments in recent years, are extrasolar planets, or exoplanets, planets which orbit around other suns. So when you look up at the night sky for pretty much every single star you can see, when you look up, you can see at least one planet orbiting around it. It's likely that there are more planets than stars in our universe. And then the second important thing is extremophiles. We know that life can survive on Earth in much more extreme environments than we ever thought possible. If you look at the depths of the ocean in the Marianas Trench, for example, life can survive there. You know, life which came from Earth can survive in these extreme environments. And then we take these two things. So we know the universe is teeming with planets, and we know that life can survive in extreme environments. And we've now suddenly got more real estate, more potential for answering that question. But at the moment, the only real sample of life we have is one. It's Earth. We haven't yet found microbial life, ancient microbial life on Mars. There is even a possibility that microbial life on Mars or ancient life on Mars could in fact be related to life on Earth. So we could be the Martian science fiction is looking for. But say we find microbial life in Mars, ancient microbial life on Mars, or on Europa or Enceladus, which are these icy moons, the planet Jupiter and Saturn. That means, and it's independent of life on Earth, that means two genesises within our one solar system. And we know that when you look up at the night sky, you know, for every star you can see there's at least one planet orbiting around it. Then we can say with quite high confidence that the universe is likely teeming with life. But then the next question is, of course, intelligent life. And I'm glad Avi mentioned ants, because the question I always like to use, or the example I always like to use, is say you were walking down the street, would you stop and pause and have a conversation with a colony of ants? You know, the answer's no, of course you wouldn't, because you can't communicate with them. So there is, of course, the possibility, and you know, every theory has some validation at the moment that there could be intelligent civilizations which have passed us by, but we are like ants to that intelligent civilization. And that, for me, is, you know, it's a complicated situation we're in. We don't yet know the answer, but there's a lot of possibilities. I like to paraphrase another quote as well, which is from the evolutionary biologist JBS Haldane, and that is, the universe is not only as strange as you can imagine, it's stranger than you can imagine.
Mm-hmm. Do you, Sarah, share Avi's excitement about Oumuamua? Because as a layperson, it's just pure Hollywood to me, and I can't wait until it's cast and the movie's made, and I want to see that scene with the scientist, not actually you, Professor Loeb, but the one in Hawaii initially, right, who spots the first anomaly. But as a science journalist, Sarah, do you share his view that this could upend everything, not upend everything we know, but confirm a lot of hopes and theories for which we don't yet have evidence?
I do feel that sometimes my personal view is irrelevant to the facts. And, you know, as I said, you know, extraordinary claims require extraordinary evidence. We haven't got that evidence yet. But if you look at the information presented and the hypothesis, there is a potential that this could be the logical explanation. There are other I can't speak, it's the evening in London. There are other potential explanations as well. But one of them is that this was something which might have come from an intelligent civilization. You can't yet discount it. Okay,
thank you. Now, let's come back to Professor Loeb, because you actually quote the same remark from Carl Sagan, that extraordinary claims require extraordinary evidence. And I believe you have a response to that. I can't find it in my notes, but do you agree broadly?
Well, first I want to say that I agree with a lot of things that Sarah said, and I highly respect what she said. But with respect to the statement she mentioned from Carl Sagan, my response is extraordinary conservatism leads to extraordinary ignorance. And I have several examples in the history of science to demonstrate it, and Sarah would agree with me. 1952, there was a paper by Otto Struve, an astronomer, saying, you know, if you have a Jupiter-like planet close to a star, it would tag the star back and forth at a level that we can measure. And in fact, if it passes in front of the star, to which there is a high likelihood if it's close to the star, then we could see the transit as it dims the light from the star when it passes in front. Now, for 4 decades, and I heard it directly from observers, nobody on time allocation committees, astronomers, nobody gave time to look for such systems. Why? Because the argument was, Jupiter is not close to the sun, and we understand why. why it was formed. And by the way, the theory that was prevailing at that time for why Jupiter formed so far from the sun is known to be wrong now. Anyway, the argument was, we understand why Jupiter is so far, therefore, why should we waste telescope time searching for it, for a close-in Jupiter? Then in 1995, a couple of astronomers found such a system. They got the Nobel Prize 3 years ago. And that opened a whole new field of exoplanets. Now, what's the moral of this story? And I can give you a lot of other stories. You know, there are many. I mean, this is a barely born baby. You might say, okay, only 4 decades. We lost only 4 decades in the history of astronomy. Well, my point is, this is a barely born baby, and there are many babies that were never born. And I'm talking about them. Now, it's a self-fulfilling prophecy to say, look, we have no evidence for extraterrestrial intelligence, while at the same time not providing funding for this search and bullying and ridiculing any person that discusses such an interpretation for anomalies. Now, why is that a self-fulfilling prophecy? Because young people, and I got a lot of emails over the past few weeks from young people saying to me, and also senior people saying to me, I completely agree with you, but I'm afraid for my job prospects to speak out. Now, we are talking about the 21st century, right? Academia. We should have learned the lesson from history. Apparently, we didn't, because in the main culture of the mainstream, you might say, okay, maybe the mainstream is conservative, doing things very carefully. Well, it's not, because over the past 4 decades, we searched for the dark matter in the universe, okay? And there were some suggestions, maybe it's a weakly interacting massive particle, maybe it's an axion. And by the way, there would be no impact on society, on our daily life, if the dark matter is an axion. Who cares? But hundreds of millions of dollars were spent on these suggestions. Nothing was found. It's part of the scientific investigation. That's completely legitimate. I have nothing against that. But one has to recognize that the funding for SETI was 3 orders of magnitude smaller, a factor of 1,000. How is that possible on a subject that appeals to the public, and the public funds science, to have the scientists ridicule any discussion on anomalies that could be related to technological signatures? Now, you might say, some scientists might say, we are worried about unidentified flying objects being discussed, and we are worried about our reputation. This is a controversial subject. Well, think about it. In ancient times, some people suggested that the human body has a soul. And as a result, there shouldn't be any anatomy. The human body should not be dissected. Now, imagine if scientists would say, this sounds like a messy subject, the human body. Some people claim it has a soul, others say not. We don't want to deal with it because of all this controversy. What would be of modern medicine? My point is, scientists have an obligation to address subjects that are of great interest to the public and to clear them up by collecting evidence. And you cannot collect evidence if there is no funding to collect the evidence. You can claim there is no evidence, but the reason that there is no evidence is because you're not investing in that. Would there be evidence for gravitational waves if LIGO was not funded at $1 billion? Obviously not.
Professor Loeb, is your impression from the reaction that you have received for going out on a limb on this matter that you will prevail in the end, and that this will become a subject that attracts more that kind of funding, and that proves itself as a theory worthy of that sort of status?
Well, you see, I'm not naive to expect, based on the historical example of Marie Antoinette. Nobody expected Marie Antoinette to accept the principles of the French Revolution, right? She benefited from the existing system. And therefore, I don't expect the senior people to change their allocation of funds and so forth at this point in time by a factor of 1,000. what I do hope is, and I wrote my book for, is the younger generation that will fill the halls of academia in the future, because the younger generation is not trapped by prejudice, by ego-motivated agenda. And I very much hope that the young generation will bring a better future. You know, when I was 18 years old, I served in the military, and I remember a statement being made, you know, when I went through the paratroopers training, that sometimes the soldier has to put his body on the barbed wire so that others can pass through. And I do feel like that these days.
Has it been bruising?
Well, yeah, I mean, it's painful. It's not, you know, a lot of people attack me personally rather than being engaged in anomalies of Oumuamua. I very much respect everyone that talks about the science and writes papers about the science, but you have a lot of people that don't write any paper. Some of them did not write a paper over a decade, and they just trash a subject that I think deserves a lot of respect. And by the way, the public has its heart in the right place. That's the amazing thing, that my book became a bestseller instantly, you know, within the first week of appearance in the US, New York Times bestseller list, in foreign countries like Germany, France. And, you know, it's quite remarkable how the public gets the point, but somehow the scientific community does not.
It is remarkable. And let's go to a member of the public, Christopher Golightly, if we can. You've been active in the chat, and you know more about the numbers of galaxies and I think some other things out there. Would you care to just repeat for people who aren't following the chat what you see to be the significance of the sheer number of galaxies in the universe?
Yes, can you hear me? I think I've unmuted myself. Yeah. Well, I got very interested in this a couple of years ago and read some articles. I mean, I'm not a physicist. I'm just an engineer. But I started seeing that there were 100 billion galaxies in the universe, and then the number went up to 2 trillion. I can't remember when. And then more recently, there was work by a chap called David Kornreich, and that went up to 10 trillion galaxies. And there are some fairly sophisticated pieces of probability mathematics out there which have calculated the likelihoods of there being a civilization of some sort across enormous vast distances. And the numbers come down to, if you estimate 1,000,000 to 1 chance or 1,000,000,000 to 1 chance, but if you were to say there's 1,000,000,000 to 1 chance per galaxy of there being sentient, intelligent life in that galaxy, 1,000,000,000 to 1, it's quite a low probability. If you multiply that by currently 10 trillion galaxies, you come to a number of, it's just an order of magnitude of something like 1,000 in the entire universe. Now, these are just orders of magnitude, they're probability calcs, but there was some more sophisticated work done on the mathematics of all this, which reckoned the probability is about 3 to 2. So it was a bit better than even, and these were serious calculations. So, you know, I think there's another, Kenneth on here has just commented that as the number of galaxies moves towards infinity, which it seems to be doing, then the probability of there being intelligent life is 1. It's highly likely. And I think we're approaching a situation where it's highly likely.
Okay, thank you very much. In a second, I'd like to come back to Professor Loeb just to address what he sees as a sort of policy significance of those kinds of numbers as they're firmed up by astronomy. But first, can we come back to Sarah? Because I'd love your view on, in a sense, the politics of all this. We're at a time in politics globally where a tremendous emphasis is put on evidence and being able for society to arrive at a body of shared facts on the basis of which to make political decisions. And there is a school of thought that I know Professor Loeb's been up against, that at this moment more than any, science needs to be taking itself very seriously. So what he calls conservatism, some might call a sober seriousness that is particularly important right now. What do you make of that argument? And you'll notice that I haven't mentioned anyone by name. Okay.
So you were asking me essentially, are we taking science seriously enough politically, and does that need to shift?
Yeah. Well, I'm saying, is this a time when we have to be particularly careful of going out on a limb with theories for which there is no sort of observable, tangible evidence?
Well, I think, first of all, it's important to get, and the media has a huge responsibility for this, and so do scientists in the media like myself, but language correct. So we need to be talking about hypothesis instead of theory, because we haven't got the exacting evidence yet. But so there are extraordinary hypotheses at the moment, but I feel like science is about, if we look at the world today, the world we live in today is a world of science fiction, compared to 100 years ago, and our future 50 years ahead of time, 100 years, we can't even begin to imagine what is to come. In terms of the media taking science seriously and politics taking science seriously, I think now more than ever, there's more of a divide globally between those who believe in science, for want of a better word, and those who have lived in this new era of misinformation with social media and stuff, where people just live in an echo chamber and they get confirmation bias towards how they feel. I think we need to listen to scientists. Scientists are the experts in their fields, and we also shouldn't be afraid to have bold hypotheses and to push out on a limb, because the only way we're going to strive forward as a society is to be all in this together. Because if we look at the concept of space exploration, if we were to greet aliens, for example, we wouldn't be someone from America or someone from Israel or someone from England meeting those aliens. We would be earthlings. We all call the same planet home, and compared to life elsewhere in the universe, even though we look quite different on Earth, we're quite similar compared to any potential alien life which might be out there. So we've got to be all in this together. I think the media and scientists need to work together at better communicating scientific thinking and scientific methods, and the same with politics as well. And I think we need to listen to science more and be in all of this together. Does that answer your question, Giles?
Yes, thank you. I mean, I'm sure we could go on forever, and then there's the question of whether different branches of science need to cooperate more closely. Perhaps before, I did promise we'd come back to you, Professor Loeb, but perhaps we could come to Hester McCreary first. Would you like to put your question about an interdisciplinary approach to Avi? Can we get to Hester?
Hello, I would if that's okay, but I'd like to stay off video if that's possible.
That's fine.
Yes, sorry. So yeah, okay. So my main question is that I'm really fascinated, and I'm not from a scientific background at all, but I am really fascinated in the challenges that scientific breakthroughs have had, from kind of like the rules of the disciplines of the discipline itself. And so every big scientific thinker had huge challenges getting their first theory accepted and then published and then accepted. And I'm just keen to know if this sort of conversation, if Avi thinks a sort of more interdisciplinary approach could help the sort of branch of science in academia level with, could help the scientists like Avi that have these thinkings could speak more openly about it if they were to be a more interdisciplinary approach. I'm sorry, I don't know if that made any sense, but I think often science is sort of shut down within it's like the walls of its own prism, and it seems like I was lucky enough to do like an interdisciplinary masters, and it seems like the more disciplines that speak to each other, and if we took Avi's thinking with maybe some psychological thinking approach, some behavioral science approach, some public policy approach, we might just get there.
What do you make of that, Professor Loeb?
Well, first I wanted to say that I agree with many of the points that Sarah made. I just wanted to point out that some of the critics that you alluded to advocate, if you look back at their previous tweets, advocate for the multiverse, for extra dimensions, for string theory, that I would regard much less supported by evidence. So how dare they talk about not having, I'm just focusing about an object that showed anomalies and saying, let's take a photograph of the next object that shows similar anomalies. I'm talking just about evidence. They were talking in the past and still talking as part of the mainstream conversation on extra dimensions that we never had evidence for, on string theory that has no contact with experimental data for 4 decades, on supersymmetry that was tested by the Large Hadron Collider and not found. So the same people are doing that and then criticizing discussion on anomalies and interpreting these anomalies in the context of one hypothesis. Okay, but now to come back to Esther's point, which I think is an excellent point. And, I grew up on a farm. I'm a farm boy, and all the titles that I have are not very relevant here. And when I grew up on a farm, I used to be mostly interested in philosophy. That was my passion. But since I grew up in Israel, I had to serve in the military. I had to, the only intellectual pursuit that I was able to do during the military service was physics, and that brought me into astrophysics. So I sort of compromised, but then I realized that this arranged marriage to astrophysics was a marriage to my true love, because astrophysics addresses some deep philosophical questions. So in answer to Esther, the fact that I'm very different than my colleagues, that I was very interested in the big questions, a philosophical point of view, definitely makes a difference. I don't behave like all the other astronomers around me. I'm thinking sideways. I'm not getting into a narrow niche and drilling very deep in it to demonstrate my intellectual gymnastics, to demonstrate my abilities, to show that I'm smart in that context. And that usually what gets you a job at a major university, that you have special skills in a very narrow niche. But for me, the more appealing aspect of pursuing science is looking at the big picture. And that there are some very big picture questions that we can ask. What was there before the Big Bang? How did the universe evolve? And are we the smartest kid on the block? What could be more fundamental than that? You are born, we are born into this life as actors on a stage without given a script. Nobody tells us what our role is in life. So we are put on this stage. And the first question you want to ask when you are put on a stage is who are the other actors? And my colleagues are saying, there are no other actors. Give us extraordinary evidence, and only then we would believe that there might be other actors around. I'm just saying, we live in a neighborhood. Why don't we check if there is a smarter kid on the block? And one simple way to check is to look for relics, just like doing archaeology. Some of these civilizations, most of them probably are not alive anymore. They are dead because most stars formed billions of years before the sun. So the civilizations that existed next to them sent things into space, and they're not around anymore, but we can find those relics, just like Voyager 1, Voyager 2 that we sent out. They would be just like plastic bottles on a beach. Most of the time you find rocks. Every now and then you find a plastic bottle that indicates a civilization exists. And we can't have a phone conversation with the Mayans. The Mayan culture is not around anymore. So looking for radio signals in space, that selects only those civilizations that are around right now. I don't want that. I want to figure out what existed before me. And the way to do that is by space archaeology. So my point is that we have an opportunity. This was a wake-up call from Oumuamua telling us that we should establish a new frontier, searching for relics of other civilizations floating in space. And the only reason I arrived in that direction, this was not a well-established folklore, in the scientific community. The only reason is because I had interest in the broader picture, and my background in interest in philosophy, I think, helped me a lot. And so I completely agree with you that a multidisciplinary training is very beneficial and unfortunately right now underappreciated. You know, the humanities are downgraded right now relative to the sciences. Some people ask, is there any value to the humanities? And my answer is there is a great value, because a lot of the technological advances being brought by science and technology these days require moral decisions. You know, in the future, we will have AI, you know, as artificial intelligence systems deciding the life and death sentence for people that have medical problems. Do we want to give a machine the authority to decide on these matters? What should be the limits of genetic engineering? What should be privacy laws about information being stored in big computers, big data sets? You know, there are lots of issues with modern technology that require the attention of the humanities. And I call it the humanities of the future. And so I am very much a Renaissance person, very much in favor of having the broader picture, the broader discussion. And of course, you will get resistance from people that are trained in very narrow disciplines. But we should overcome this resistance by looking at the bigger benefit to society.
Thank you. Let me just pass on to you a question from a colleague in the chat. This is a fairly technical one. I will pass it on unvarnished because I don't know what it means. What does Professor Loeb think about the dark forest theory, and should we be searching for extraterrestrial intelligence or hiding from it?
That's a very good question. So when you enter a room full of strangers, the wise thing to do is stay quiet, not speak. First, you want to listen, because there might be a predator out there that will risk your existence. Unfortunately, we were not smart enough to do that because we transmitted radio signals for more than a century now. So there is a bubble of radio waves propagating out. And if there is any civilization with radio telescopes within 100 light years, they know about us and we might hear back from them. It may take decades before we hear back, but the consequences will come just like this giant rock that killed the dinosaurs. They might come. So that's an important point to keep in mind. The other thing I wanted to mention is advanced civilization, very advanced civilizations, you know, might not be interested in any contact with us because it would degrade their quality of life. So they build a cocoon and live inside of it without establishing contact. And that doesn't mean that we cannot find about them, because they still have to throw some trash. And, you know, we can be just like those investigative journalists that go through the trash cans of celebrities in Hollywood, trying to figure out something about their private lives.
Thank you very much. And I before we run out of time, I just want to say to everybody, please, if you have questions, put them in the chat or raise your hand. And that includes Sarah as a fellow journalist. But I just want to come back to something that Andrew Girdwood said 42 minutes in, and we are discussing encounter etiquette, first encounter etiquette. Were we really? If so, I missed that. What is it? Andrew, are you there?
Yes, hi. It was something that Sarah was saying. We have to think about how we.
Oh, I see. I'm sorry.
Humanity if we met aliens.
I'm sorry. I missed that point. Avi, let me come back to you. If you had the funding on a scale that you point out has been devoted to projects like the Large Hadron Collider, what would you use it for?
I would put cameras within the orbit of the Earth around the sun, such that one of them will be close to any interstellar object that crosses that region, close enough to take a close-up photo, so that we can search through those objects and find the plastic bottles among the rocks. I think it's a new frontier of space archaeology, and we should engage in that without prejudice. A lot of people think they know the answer in advance. I'm all in favor, even though I'm a theorist, all in favor of collecting evidence. You know, if we do that for decades and we don't find anything, perhaps we should change our strategy, but we haven't done that. We have just been searching for radio signals from space. We haven't done space archaeology of this type because the first interstellar object detected was Oumuamua.
And can you explain the strange coincidence by which almost immediately after that, the second one was detected?
Oh yeah, well, that was 2019, 2 years later, and it's called Borisov, and because it was discovered by a Russian amateur astronomer, Gennady Borisov, and that one looked exactly like a comet, you know, that we have seen many times before. And so my colleagues came to me and said, well, Borisov looks like a comet, doesn't it convince you that Oumuamua is also natural? To which I said, you know, if you find a plastic bottle on the beach, and later you find rocks, it doesn't make the plastic bottle a rock. And another response is, you know, when I met my wife, she looked special to me. The fact that I met a lot of people afterwards didn't change that fact. In fact, you know, the fact that Borisov is so typical makes Oumuamua even more special.
Okay. Look, I want to give you both a chance to address the question that we started with: are we alone in the universe? I'll come to you first, Sarah, because I've seen saying in an interview with Sky, I think, that you think we've got to the point where the onus, and correct me if I've misunderstood this, where the onus is on the scientists to disprove rather than prove that there is intelligent life elsewhere in the universe. Is that your position?
I think what we're getting to is that a stage where there's so much evidence, not in terms of intelligent life, but in terms of it's likely, it's highly probable within the next few decades, we will know whether we're alone or not. But in terms of microbial life elsewhere in the solar system, and as I was explaining earlier, that then takes us on, you know, physics goes from 1 to infinity. 1 could be an anomaly, but if you've got 2 independent genesis, you know, that can go to infinity. So, you know, it is likely that within our lifetimes we will answer that question. But the big question is really intelligent life. Is there intelligent life out there? Are we the most intelligent thing, or are we the least intelligent thing? Are there far advanced civilizations? You know, and Professor Loeb mentioned archaeology, and you think SETI is listening, for a better word, for signals in space. We're emitting these signals. Say we get a signal and we prove it is from an intelligent alien civilization. Because of the vast distances in space and the limits of our technology, we'll be learning about their past, even though they're, you know, they've sent that signal out. So it's you know, the universe is a vast place, and we would be ignorant, and it's myopic and short-sighted to think that we're the only life and that there isn't something beyond Earth. And I encourage everyone after this just to look up at the night sky and to wonder with awe about what else is out there, because we're in this spaceship together and the night sky is our window. But for me to give you an answer, as I said earlier, it would be religion. But I think the evidence is leaning strongly towards the fact that we aren't alone.
Thank you, Sarah. Great advice. Stare up at the night sky. I defy you not to be completely freaked out, but I still love doing it. Coming back finally again to you, Professor Loeb, I'd like to split the "are we alone in the universe" question into 2 parts, if I may. First, referring back to what Christopher was saying about the sheer number of galaxies in the observed universe, which seems to grow all the time. How does that affect your thinking about the theoretical probability of not just life, but intelligent life elsewhere? You know, what is your real view on that? And then the second half of the same question is, when you close your eyes and drift off to sleep, thinking perhaps about the last 3 years, since you first heard about Oumuamua, what do you actually think it is? If you had been up close as it zipped past, what would you have seen?
Right. So to answer your first question, what really impresses me is not so much how many galaxies exist in the universe and how many stars are in our galaxies, because that altogether, you know, the number is zeta, 10 to the power 21, more than the number of grains of sand on all beaches on Earth. It's not that number. It's the fact that the Kepler satellite data that was analyzed last year indicates that about half, plus or minus a quarter, of all sun-like stars, stars that look like the sun, have a planet roughly the size of the Earth at roughly the same separation. And what that means is that the temperature on the surface of that planet, you know, and there are billions of them in the Milky Way galaxy alone, the temperature would be similar to that on Earth, room temperature. And what that means is that if you reproduce the same conditions, in my view, you're very likely to get similar outcomes. because after decades of practicing astronomy, the one lesson, if I had to summarize my career in astronomy, the one lesson I learned from the sky is a sense of modesty. That not only we are not at the center of the universe, as Aristotle advocated, we are also, our backyard is not special. The Earth-Sun system is very common. Mm-hmm. And why should we feel that we are so unique? You know, my daughters, when they were infants, they thought that they are the smartest in the world. But once we took them to the kindergarten and they saw other kids, their perception of reality changed. And that's a way to mature. Our civilization has not matured yet. Now, of course, if you ask my daughters, if you asked at that time, ask them, they would tell you they would much rather stay at home and keep the illusion. And of course, we can keep the illusion by not collecting data, by not trying to look for others, because we are saying, give us extraordinary evidence while not even seeking the extraordinary evidence. Obviously, we can bury our head in the sand and be happy. But that is not the way science should progress. We should collect as much evidence as possible, because this is a fundamentally important question. Now, coming back to your second question about what do I imagine? So I, based on the experience with 2020 SO, which was just a rocket booster that we launched that showed similar features, similar qualities to those of Oumuamua, I'm not sure it's actually a light sail, just a thin piece of material. You know, it could be a surface layer ripped apart from a spaceship. Could be, I don't know what it is, but not natural, okay? So that's why I want to have a photograph. A picture would really tell us that it's not a rock. And my point is very simple. I'm not claiming that I have 100% certainty in this hypothesis. I'm just saying it should be on the table and it should motivate our thinking. In my book, I call it Oumuamua's wager. Just like Pascal, the philosopher, had a wager about God. You know, the significance of Oumuamua being a technological relic is so great that we cannot ignore it.
Professor Loeb, thank you so much for joining us. Sarah Cruddas, thank you very much. Thanks to everybody else. And I'm deeply aware that lots of very profound and complicated thinking has zipped past me, a bit like Oumuamua in the cosmos, but this time in the chat. The phrase space archaeology leaps out at me as one that I'd never heard before and have learned today. The phrase of the analogy with the body on a barbed wire, I had read in the book, which I commend to everybody. It's just a great read. And 66,000 words is short, so that's another thing to commend it. But I hope, Professor Loeb, that the experience of being on the barbed wire doesn't diminish your enthusiasm for science in the next phase of your career. Thanks again for joining us. Thanks again to Sarah and to everybody. See you again soon.